instead T2 by T1 is equal B2 by B1 to power gamma minus 1 over gamma. T2 over T1 equal B2 over B1 to power gamma minus 1 over gamma. B2 over B1 sometimes is given direct with the name of pressure ratio. Pressure ratio. So pressure ratio is B2 minus B1. Once you take it this pressure ratio, so it's the same ratio B2 over B1. So it is this RB to power gamma minus 1 over gamma. Gamma minus 1 over gamma. What is gamma? Gamma for air, like for example, air is 1.4. From 2 to 3 is Q added. Constant pressure, Q added. So CB delta T, which T? From 3 to 3. So T3 minus T4, T2. CB, T3 minus T2. Whatever the unit here is. The third cycle here for expansion of the turbine. Expansion happened between 3 and 4. So this is work turbine is equal to CB T3 minus T4. This is the rejected part, which is normally not calculated. So at the end, efficiency at all, it should be as per the general equation. Work net or work turbine divided by Q added. But actually, we can't set here work turbine only. Why? Because work compressor, it's not a small value, same like the work turbine, the pump. For the pump, it is small related to the turbine. So neglect. Here, no. Here is the compressor, it's not small related to the turbine. So in this case, we should consider the work compressor for the equation. But by the way, all it does have CB difference temperature. So we can substitute for that to obtain finally simple equation function for the temperature. So efficiency is equal what? Efficiency is equal 1 minus T1 over T2. Where is it? Yes. Efficiency is equal 1 minus T1 over T2. If you have pressure ratio, can you calculate this? Yes. T1 over T2 is equal what? 1 over RB, gamma minus 1 over gamma. Okay. 1 over RB, gamma minus 1 over gamma. Here, effect of pressure ratio on efficiency and power. Pressure ratio is RB, which is mean B2 divided by B1. So what is the effect for pressure ratio? Actually, pressure ratio, if you increase pressure ratio at a certain limit, you will obtain the work net maximum. This is the maximum RB? No, no, no. You can continue pressure ratio to increase. But in this case, what happened? Normally, the work is going to be decreased again. So the work is going to increase, then to be maximum, and then decrease. But for efficiency, efficiency is increased all the time. If you go to increase the temperature, efficiency increase due to the pressure ratio increase. So it will be increased up to reach the maximum RB. And once you reach to the maximum RB, the efficiency now, it will be the maximum efficiency which is indicated to Carnot cycle, which is have the maximum efficiency at all. Read the question, please. Here, an air standard Brighton cycle, the air enters the compressor at 0.1 megapascal and 15 slices. Pressure leaving the compressor is 1 megapascal. Maximum temperature is 1100 Celsius. Let's give me the pressure and temperature at each point in the cycle. And the work of turbine, work compressor, and efficiency. Normally, the exam question, it's not asked for everything like this, but just I bring this to know how to apply for the problem. Normally, the shape of the problem for this type, ask for one element, is give to use this whole cycle like this. Sometimes give you part, but sometimes give you the total shape of the cycle like this cycle, give you total cycle, and ask for one element, give you the given for related for one element or two elements, something like this, but ask for one element only. Okay, ask for compressor, ask for turbine, something like that. Okay, so by the way, just I tell you how to solve it, to be aware how to apply for this problem. Actually, the given is B1 equal 0.1 mega, B2 equal 1 mega. So from this, we can calculate RB, which is B2 by B1 is equal 1 divided by 0.1, which is equal 10. And temperature 1 is 15 Celsius. So plus 273. Don't forget, please, to change it from Celsius to Kelvin. To change it from Celsius to Kelvin. This is very important, please. Okay. 882. And we have temperature maximum on the cycle. Which one is the maximum temperature on the cycle? The maximum temperature on the cycle is T3, which is related to output of the combustion chamber. 1100. So plus 273 equal 3731. This is Kelvin. This is Kelvin. What else? Yes. Work compressor is equal to CB delta T. Where is delta T between what and what? The compressor. Here's this compressor during combustion chamber. Then turbine. You can write it like this. Not important to write the exact shape. Combustion chamber. So 1, 2, 3, 4. To know where is the number. So T1 minus T2 or T2 minus T1. But still, we don't have other temperatures. So at the beginning, it should give going to calculate the other temperature. T2 by T1 equal B2 by B1 gamma minus 1 over gamma. Also T4 by T3 equal B4 by B3 gamma minus 1 over gamma. What is B2 over B1? Or B, and B2 is equal to B3, and B1 is equal to B4. Constant division. So 3 over 4, which is reciprocal for this RB. So it's better to write it 3 over 4, 3 over 4. So I can write it RB, gamma minus 1 over gamma. RB, gamma minus 1 over gamma. So once you calculate one element here, multiply here for T1, get it T2. And here just like divide T3 by this value, you get it T4. Once you get T2 and T4, from here you can get T2 and T4. Once you get it, you can calculate anything. Work turbine, for example, CB, where is 3 and 4? So T3 minus T4. If you ask only for efficiency, no problem. Efficiency equal 1 minus T1 over T2. Or 1 minus 1 over RB, gamma minus 1 over gamma. Just I check the equation. Yes. Yes, correct. Any question? If you have any question, tell me, please. Which one is false? Write on the chat, please.
Letter E.
Share with us and type in chat. Volumetric efficiency is high. Multi-stage compressor, the isothermal compression is achieved by
running the compressor at a very low speed.
Intercooler A. Intercooler, sir. A.
running compressor at very slow speed.
Yeah.
Why multi-stage compression is required? You remember the shape of pressure line? Here, it's close. It is far. So this expansion for turbine, you obtain more expansion. If you compress here, it's better than compressed here. Actually, it's not easy to compress here directly. So what we do? I compress here to a certain limit here. Then intercooler, make cooling. Then increase more pressure again, increase pressure, then cooling. Pressure again, then cooling, then pressure again. What we'll see here at all? We'll found you obtain the same pressure you need, but the total of this sum of pressures, small pressures, is less than if you go direct here. So the multi-stage is decrease the power consumed for the compressor. This shape define what we said. This is the first stage here, going to intercooler, then the second stage here. This gives you the shape for saving work. Adiabatic compression is one image.
Option B, no heat leaves or enters the compressor.
Leaves your
A, sir. A temperature remains constant.
No. It's
Please share
B.
with us.
B.
No heat leaves or enters the compressor cylinder during compression.
Sorry,
The capacity of compressor
think,
is 5 meter cube per
copy
minute.
zero.
Refer to
free air.
Free air. Free air.
No, sir. This is compressed air. Compressed air. See, and D. Compressed
No,
air
it's-
is delivery pressure.
Free air.
free air. Overall, isothermal efficiency of compressor is defined the ratio of
Isothermal.
Yeah. Isothermal height to the
D, sir. D.
please write on the chat. I don't hear anyone.
air.
Just a minute, maybe the voice here is increased. Yes.
A.
D, sir.
A.
Yeah, the volume from my computer is not increased.
D, sir. D.
Isothermal horsepower to brake horsepower. What's most efficient method of compression, compressing air?
Isothermal.
Isothermally.
Adiabatically.
Isothermally.
Isothermal.
Yes. Let's hear this equation. I think we studied last session or something like this when we talk about 4b to power n, and when n equal to 1, this is isothermal, equal to gamma, this is adiabatic, and adiabatic is the maximum work happen. This is the minimum work happen. This is in between. Maximum work is done in compressing air when the compression is
Adiabatic.
Adiabatic.
active.
B.
What is isothermal efficiency and isentropic efficiency? This is used for the element itself. Here, isothermal efficiency for the compressor, it is the work theoretical divided by work actual. So what is work theoretical and work actual? Theoretical, it is isentropic here. This is isentropic part. This is work theoretical. Instead, work theoretical was work isentropic. So this is a theoretical work for ideal case, but actual is going like this. So for compressor, it makes sense to the work for the real is used more than the ideal. Turbine is opposite. Pressure and temperature condition of air at section of compressor.
E.
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 E for
Pressure
elephant.
slightly less than atmospheric and the pressure is slightly more than atmospheric. Isothermal compression efficiency can be attained by running the compressor
At low speed.
Very low.
at very slow speed. The compressor capacity with decrease in suction temperature.
Increase.
Increase. Isothermal compression efficiency, even when running at high speed, can be approached by using
Multi-stage.
C.
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 Both A and B.
A and B. C, sir. Yeah.
A and B, yes. Compression efficiency is compared against
Both C. Isothermal and
And adiabatic.
isothermal compression.
okay.
Air plants employ following type of compressor.
B.
Flow.
D, sir. Combination of above.
Axial flow.
Combination. Axial flow, yeah.
Axial flow. Intercooling in compressor. Why? Remember the figure I discussed with
B,
you.
sir. Results in saving the power. B, sir.
Results in saving power in compressing a given volume to given pressure. Yes. What will be the volume of air at 27 Celsius if its volume 27 Celsius is 1.5 meter cube? Here requested is volume. This is T1, and volume if its volume at this T2, this is a V2. So V1 by V2, V1 over T2, V1 over 1.5, T1 plus 273, plus 273. So T1 it will be 600, 300. So V1 is equal.
Answer is A.
Answer it will be A.
So this formula by which law, sir? And how to remember this formula? By which application?
Temperature and the volume is directly proportional together.
This is
Gilesic, I think so.
Sorry, sir. Gale, sir.
Realistic, I think so. I remember.
Okay, sir. Okay, sir. Okay.
Work done per unit mass of air in compression will be least when n is equal to
1.
1. Exactly. Isothermal compression is most efficient, but is not practicable because
It is impossible in practice.
D compressor has to run at very slow speed to achieve it.
working at very slow speed.
D, sir. Yeah.
Ratio of indicative horsepower to brake horsepower.
Mechanical efficiency.
Mechanical efficiency. Ratio of work done per cycle to the swept volume in case of compressor is called
Compression ratio.
no.
No.
Work done per cycle to the swept
Mean
volume.
effective pressure. Mean effective pressure.
Mean effective pressure.
Let's see what's meaning of swept volume and effective swept volume and so on.
Yeah, sir.
Here, this is a cycle here. 1, 2, 3, 4. From 1 up to the end, this is the total volume. Makes sense. But from 1 up to the maximum volume you can use it, this is swept volume. Okay, so this is not used, it's like useless. It said clearance volume. It said what? Clearance volume, this area. But from this point to this volume is the swept volume.
Swept volume.
1 to 4, this is effective swept volume. Okay, so volumetric efficiency, it is effective swept volume to swept volume.
Okay, sir.
And the clearance ratio is the clearance volume to the swept volume. Clearance volume to the swept volume. Last thing here, compression ratio. Compression ratio here is defined for the reciprocating like this. This is clearance. Is said volume top dead center. Volume of top dead center. Okay. This is the clearance actually. We tend to reach to the maximum, which is means 0. And if you plus this is to swept volume, this is refer almost to the total volume. So if you divide the total, which is the swept plus clearance or volume top dead center, divided to volume for top dead center, this is compression ratio. This is what compression ratio. 1 minute, please. Cylinder clearance in a compressor should be
As small as possible. B.
yes. Ratio of compression is ratio of